Welcome to the Deep Dive, the place where we cut through the noise and give you the essential intelligence on the most complex topics.
And today we are definitely in complex territory.
We really are. If you need a shortcut to understanding how Canada is planning to power the next digital revolution and the massive scale of it, we've got you covered. We're going deep into the hyper-technical world of infrastructure compliance.
Right, specifically for energy and telecommunications in Ontario. Our mission today is to pull together brand new energy legislation, the really granular physical safety standards, and the rules for digital equipment.
And we're doing this because the entire system is being stress tested by one central fact.
A forecast of just, well, unprecedented power consumption.
And that fact is our primary hook. The system operator, the IESO, is forecasting that electricity demand is going to surge by a staggering 75%.
75% over the next 25 years.
It's driven by electrification, industrial growth, and, critically, this global rush to build out AI capacity and the massive data centers that run it all.
So the question is, can the rules that govern utility poles and network gear actually handle that kind of pressure safely?
That is the question. And that dramatic forecast you mentioned, well, policy has to catch up fast.
And it looks like it's trying to. The response landed on June 3rd with Bill 40 to protect Ontario by securing Affordable Energy for Generations Act 2025.
Okay, let's unpack Bill 40. The source material points to a really significant, almost philosophical shift in that act. What's the biggest change for the regulatory bodies?
The shift is that Bill 40 formally codifies economic growth as a statutory objective.
That sounds simple, but it's huge, isn't it?
It's huge because, previously these bodies focused mostly on reliability, safety, stable pricing. Now that priority of growth is legally baked right into their core mission.
So this isn't just a memo. This is now mandatory for the IESO, the Independent Electricity System Operator, and the OED, the Ontario Energy Board.
Exactly. They are legally locked in. They have to consider economic growth and job creation in pretty much every planning and regulatory decision they make now.
It forces them to be explicitly pro-growth, to target that massive expansion needed for the 75% surge.
Correct. Which, of course, directly influences how they manage the sources of that demand.
And that brings us to the high-load culprits, data centers. How does Bill 40 handle them? Because you can't treat a massive hyperscale data center like a normal customer.
No, you can't. So the bill introduces new regulation-making powers. It's under a new section, 28.1 of the Electricity Act, and it's aimed at what they call specified load facilities.
So basically a special class for data centers and other huge consumers.
Exactly. And it gives them the power to set specific, and I'd imagine very strict, connection requirements for these facilities when they hook up to the grid.
Which signals their connection process is going to be way more rigorous than for a standard hookup. It has to be to handle that load.
Absolutely. And there's a key detail for anyone tracking projects right now.
Cool.
A very distinct legislative line has been drawn. If a facility made a connection request before Bill 40 was introduced on June 3rd, 2025, these new, more stringent rules won't apply.
Ah, so they're grandfathering in the projects already in the pipeline.
Seems that way. It suggests they're trying to regulate the next wave of development without, penalizing projects that were already moving forward.
That's a critical distinction. And what about security? The bill touches on that too, right?
It does. It acknowledges the geopolitical risk of rapidly expanding critical infrastructure. It gives a pathway to implement restrictions on hostile foreign participants and helps utilities fund the investments needed to secure the system.
So that's the policy level. High-speed growth, legally mandated.
Right. But if Bill 40 sets the policy, how do the engineers on the ground make sure this massive expansion is actually physically safe?
Especially when you're adding new capacity onto infrastructure that could be decades old.
That's where we shift from the legislature to the enforcement body.
We shift to the Electrical Safety Authority,
Right.
the ESA.
Exactly. They enforce Ontario Regulation 2204. And what's interesting here is that the regulation is objective-based.
Objective-based, meaning it's not just a checklist.
Right. The distributor has to actively prove they're reducing electrical safety hazards, usually by adhering to technical standards like CSA C22 number 1 for overhead systems.
So the onus is on them to demonstrate safety, not just follow a rule book.
Precisely. And our sources say that even if there are bureaucratic shifts, like licensed distribution companies becoming licensed load-serving entities, the safety oversight from the ESA stays constant. The bar remains high.
Okay, here's where it gets really tangible. The micro rules for sharing utility poles, joint use.
This is where safety gets down to millimeters. And the level of detail is, well, it's staggering, but it's essential for worker safety.
Give us an example.
Okay, so when a telecom provider makes vertical attachments on a pole, they have to be grouped. The rule states that a minimum continuous surface of 60% of the Hydro 1 pole must stay clear.
60%, and that's specifically for a person.
Yes. That 60% is purely for climbing safety, so an electrician can safely maneuver their gear without getting tangled up. It's a human body-based measurement.
That really defines the physical limit of how much you can expand on an existing pole. What about the hardware itself?
For attachments using standoff brackets, there's a required clearance of 80 millimeters minimum.
80 millimeters, so just over 3 inches.
And that's a hard minimum. That tiny measurement dictates network installation, ensuring nothing gets into safety zones or causes inductive heating.
And if you ignore these rules...
The repercussions are immediate, and the financial side is designed to hurt.
How so?
For an unauthorized attachment, Hydro One can demand a new permit or just have it removed within 30 days. But the money part, if a partner is late on payments, the interest rate is 1.5% per month, compounded.
1.5% a month. That works out too.
19.56% per year.
Wow. That's not a penalty, that's a statement. It's designed to be punitive.
It's extremely punitive. It ensures that compliance managers are auditing every millimeter and every single invoice very, very closely.
Now let's connect this back to the 75% growth challenge and climate. Extreme weather is the new normal.
And the standards have adapted. The latest versions of the CSA Overhead Systems Standard now formally include new definitions.
Like what?
Extreme weather loading event, storm hardening, and system resilience. This isn't just advice anymore, it's codified design language.
And the methodology for predicting stress has changed too, right?
It's a fundamental change. Designers are now required to use regional and spatial category observation methods.
Meaning they can't just look at what happened in the past.
Exactly. They can no longer rely solely on historical weather data. They have to acknowledge that the climate of the past is not a reliable predictor and design for future, regionally specific, extreme stresses. That's a huge shift from history to prediction.
Okay, let's pivot to the digital side, the actual equipment that attaches to these systems. We're moving from Hydro on poles to ISD certification.
Right. Innovation Science and Economic Development Canada. They manage the radio spectrum and equipment compliance under the Radio Communication Act. They're the gatekeeper.
And they have different tiers of compliance.
Two main ones. Category I equipment faces the highest bar, full certification.
Which means getting a technical acceptance certificate, a TAC, from an ISD-recognized body, and then getting listed on the radio equipment list.
A very transparent pre-market approval process.
And Category 2.
That's for lower-risk devices. It requires a supplier's declaration of conformity, or SD2C. The manufacturer still has to ensure compliance and keep all the test reports just in case ISD wants to audit them later.
So pre-market approval versus self-declaration subject to audit.
That's the core difference. And then, separate from radio waves, any terminal equipment that physically connects to a carrier network, like a modem, has to follow its own rules, like the requirements in CSO3.
So layers of compliance, one for radio, one for the physical plug.
And speaking of physical connections, let's talk about the Canadian Electrical Code, the CE Code. This is about wiring inside buildings, and it is obsessed with one thing.
Separation.
Total separation between power and communication systems.
Why is that so critical?
Because they manage fundamentally different types of electricity. Communication systems under Section 60 usually have safe Class 2 current and voltage limits. You absolutely cannot risk a high-voltage power surge crossing over into a sensitive, low-voltage communication cable.
So what's the core rule?
Communication conductors must be separated from electric light, power, or Class 1 circuits. If they're in the same raceway, they have to be separated by a physical, robust partition. They can't share air.
And you need protection right at the point of entry.
Absolutely. Rule 6200 says approved primary protectors must be installed on each exposed communication circuit, right where the wires enter the building. It's your first line of defense against something like a lightning strike.
This brings up an interesting point about grounding. We tend to use grounding and bonding as the same thing, but in compliance, they're legally distinct.
They are, and the distinction is critical for safety. It's defined in the CSA standard. It covers protective bonding connecting metal parts for electrical safety, against shock and fire.
Okay, so that's for protecting people.
Right. And the standard explicitly excludes grounding that's applied only for functional purposes.
Functional grounding, meaning what?
Meaning grounding for things like lightning protection or preventing electrical noise and interference in your computer circuits. So safety bonding protects people. Functional grounding protects the data. You need both, but they serve different legal purposes.
That clarity is essential. Now, for maybe the most surprising compliance stream we found, it ties power, data, and public safety together.
Smart meters.
Specifically, the data inside your meter being critical for fire investigations.
That's right. The new generation of smart meters stores time reference consumption data using EEPROM.
Electrically erasable, programmable, read-only memory. It's a mouthful.
It is, but you can think of it as a kind of digital carbon paper. It's non-volatile memory
Which is so crucial during a disaster like a fire. Why?
because it preserves the data even if the power is cut or the meter itself is destroyed in the fire. This means the Office of the Fire Marshal, the OFM, can retrieve a perfect, time-stamped log of tower activity.
So they can see when consumption spiked, when it dropped, when
Yeah.
power stopped completely.
Exactly. It's invaluable forensic evidence for investigation. Using a common system as an example, the meters store the data, gatekeepers collect it, and then a management system exports it all in a standard format. It gives investigators a verifiable timeline.
That's incredible. The compliance web goes right down to the data preserved in a fire. Okay, finally, let's look at the facilities driving this 75% growth, the data centers themselves.
If they're going to use that much power, they have to be unbelievably reliable. They adhere to a global standard, TIA 942.
And the highest level, the one for critical AI or financial systems, is Tier 4. What does that actually mean?
Tier 4 demands a fault-tolerant system. It means dual active distribution paths. If any single component fails, a breaker, a pump, a chiller, the parallel system takes over instantly, with zero interruption.
And what does that mean in uptime?
It guarantees 99.995% availability.
Which sounds like a lot, but what is that in real time?
It translates to a maximum of 26 minutes of unscheduled downtime per year.
26 minutes a year. That incredible pressure for flawless operation is exactly why the grid is facing that 75% surge.
They cannot afford to stop. So the grid supporting them cannot afford to stop.
And achieving Tier 4 requires that same obsession with separation we saw in the CE code.
Absolutely. TIA 942 mandates strict physical separation. Power and communication cables have to be in separate pathways. They require separation of hot and cold aisles for thermal management. Redundancy is built into the literal layout of the building.
And the security has to match that physical rigor.
It does. Single point of entry, government-issued ID for everyone, and immediate removal for any unauthorized work on building systems. The compliance is a total system of power, data, space, and human access control.
So we've gone from a massive 75% energy prediction and the growth mandates of Bill 40, all the way down to the 80mm clearance on a utility pole and the data inside a burning smart meter. It's an incredibly dense compliance environment.
It is. And the final thought we'll leave you with connects that political drive right back to the physical reality. Bill 40 legally demands that energy agencies prioritize economic growth. At the same time, their biggest new customers, the data centers, demand extreme guaranteed reliability, 99.995%.
So there's a tension there.
A huge one. Given that the CSA standards for our physical infrastructure now have to account for extreme weather loading events, what trade-offs, if any, are implied when policymakers are pushing for such aggressive growth while also maintaining these decades-old, incredibly detailed safety requirements?
The next 25 years will be a real test.
It's a test of whether the pace of expansion or the detailed adherence to safety is the thing that holds the line.